All right, in this video, we're going to learn about linear graphs. And what we mean by that is how do you graph a line if, uh, I have some leftover stuff from before. How do you graph a line if we know the equation of it? And if we see the graph itself, how can we get the equation from that? So that's the two things we're going to try to do. So our objective will be to be able to graph a line when given the equation. Okay, that's one of our objectives. And another objective is going to be, and actually I'm just going to like put little stars in indicate there's more than one objective, uh, to be able to um, find the equation of a line when given the graph. Okay, so here's our two objectives: graph line when given the equation, and find the equation line when given the graph. So we have to be able to go both ways. All right, so let's just take a look at an example here. I'm just going to randomly pick one point and randomly pick another point up here somewhere. And you can make any line if you have 2 points. So I'm just going to make a line that goes to those 2 points. And we're just going to say that line goes on forever in both directions. And if it's not perfect, that's okay. You get the idea. But what we do know is that it goes through this point and it goes through this point. And hopefully that's somewhat of a straight line there. Okay. All right. So there's two elements of a line that are important that we're going to take note of. One element is going to be where it crosses the y-axis. We call that the y-intercept. The y-intercept is the place where it crosses the y-axis. So that's one thing that's really important. The other thing that's going to be important is our slope. And our slope is going to be basically how far we go up. We call that the rise or the change in y, and how far we go over. That's a change in x. So the slope is going to be a relationship between how much we go up versus how much we go over when we get from one point to another. So it's our rise over run, also known as change in y over change in x. That's our slope. Okay. So if we have a steep slope, then we are going to go up a lot and go over just a little. If we have, and this is from going from left to right, if it's a steep slope, you're going to go up a lot and just go over a little. If we have a shallow slope, then that means we're going to go up very little and go over a lot. Okay, so it's a relationship between how much you go up versus how much you go over. That's the slope. All right, so the general equation looks like this. And this is the general equation for a line. Now, there are different types of forms, but the one we are specifically looking at is what's called the slope-intercept form, the slope-intercept form. And the slope-intercept form is such that this one right here is the slope, and this one right here is the intercept. So the B is what we call the intercept, the y-intercept, and the M is the slope. Okay, so this is called the slope-intercept form of the equation because it gives us the slope and it gives us the intercept. So that's what we're going to take a look at. All right, so given that general equation of the line, we take a look at this over here and say, hey, can I find my slope by looking at this particular problem? And the answer is yes. I can figure out how much I'm going up to get from this point to this point. And I'm going up 1, 2, 3, 4, 5. So my change in y appears to be 5. So I'm going to write this first, change y over change in x. So my change in y appears to be 5. My change in x is 1, 2, 3. Okay, and I just want to take note real quick the fact that they are both positive. They're both positive because I am, when I get from one point to the other, I am going up 5. I'm going 1, 2, 3, 4, 5. I'm going up. So therefore my change in y is getting bigger. And so that's why it's an increase. So it's positive 5. And then when I go from this spot to this spot, getting from this point to this point, when I go right, I'm getting bigger in my x. I'm going from a negative value to 0. I'm getting bigger. So change in x is also positive. So if you're going up, it's positive. If you're going right, it's positive. So it's a positive or a positive. Your slope is positive 5/3. Your y-intercept is going to be wherever it crosses the y-axis. In this case, it is at 5. So now it's just a matter of plugging into your equation. So the equation is going to be y equals m, which is 5/3. And by the way, I'll go ahead and say m over here. M is the same thing as your slope. Okay, m is 5/3, and then you say x. That's kind of weird. That's red now, so let's go ahead and make that green. X, and then your y-intercept is 5, so say plus 5. All right, so that's it. That's your equation. You went from graph to equation. All you got to do is find two things, your slope and your y-intercept, and then you're good to go. All right, now let's go the other way. Let's say we have an equation and we want a graph. So the equation might be y is equal to negative 2/3 x minus 1. Okay, there's just a random equation there. So what I want to do is pull off the slope, and I want to pull off the y-intercept. Okay, so the slope, which is called our m, same thing as the slope, it's going to be negative 2/3. And our y-intercept is going to be minus 1. Okay, notice how up here it says plus b. So therefore, if we have a minus, then that means we're going to be crossing the y-axis on the negative side. So y-intercept is equal to -1. All right, so if we go to graph this, what we want to do is start by plotting a point at the y-intercept, which is right here, -1. The next thing is to use our slope. Now, what do we do if we have a negative slope? Well, if you have a negative slope, what you want to do is you can put the negative wherever you want to. You can put it in the numerator, or you can put it in the denominator, or you can just remember, okay, if going left to right is uphill when the slope is positive, then I know I'm going to be going downhill when I go from left to right. So positive slope would be going uphill and going left to right. So when you're going this way, you're going uphill when you have a positive slope. So when you go this way, you're going to go downhill when you have a negative slope. So we know it's going to go down. So that's just a way to check ourselves. So we can put the negative in the numerator or the denominator. I prefer to put it in the numerator. Okay, and that tells me that I'm going to go down 2, and then I go right 3. So that's what that says right there. So by putting the numerator, it says I go down 2, and then I go right 3. So remember, it's rise over run. So this is whether I go up or down. This is whether I go right or left. And negative means I go down. Positive means I go right. So from this spot here, this green dot, I'm going to go down 2, 1, 2, and I'm going to go right 3. So 1, 2, 3. So I'm going down 2. This means I'm going down 2, and I'm going to go right 3. So I'm changing x. Sorry, changing y is what I meant to say. My change in y is going to be -2, and then my change in x is going to be +3. Okay, and now I can connect those two dots, and I can make a line, because between any two points, I can make a line. Okay, and so that's how you graph a line when given the equation. Okay, you identify your y-intercept, and you plot that point. You identify your slope, and then you make your next point using the slope. All right, so one more example, and then we're going to call it good. So the next example is what happens if I have some crazy jazz like this. 2y plus 3x is equal to 2x plus 1. We'll do that. All right, so this is a y here. So what happens if we get something weird that doesn't look like it's in the right form? And the answer is we put it in the right form. Okay, so we're going to start by subtracting 3x from both sides, because we want to get the 2y by itself. Okay, and by doing that, I get 2y on the left. I get 2x minus 3x, which is -x on the right. I'm not there yet. Like I have some leftover stuff here. I'm not done because I need y by itself, because it's y equals mx plus b. So I got to divide that by 2, and I got to divide this whole side by 2. Whatever I do to one side, you have to do the other. So I have y over here. On this side, I have -x plus 1 over 2. Well, that's the same thing as saying -x over 2 plus 1/2. Okay, if you have two things in the numerator added together and one thing in the denominator, you can split it up into two separate fractions. All right, Well, I'm going to change the form a little bit more. I want to say -1/2 times x plus 1/2, so I can easily see my slope. So -x/2 is the same thing as -1/2 times x. Those are identical. All right, so the slope, I'm going to identify with the red here. The slope is right there. Okay, and that's going to be your slope, and your y-intercept is right here. And so the slope is going to be -1/2. Okay, which means you're going to have to choose whether to put the negative in the numerator or the denominator. I'll go ahead and put it in the numerator, and the y-intercept is going to be 1/2. Okay, so that means by putting the numerator, I'm going to go down 1 and over 2. All right, so graphing it quickly, we're going to have the y-intercept of positive 1/2. So that's going to be just right here, right between 0 and 1. And then since the slope is -1/2, we're going to go down 1 and over 2. So again, it should be going downhill because it's negative slope. So down 1 and over 2 puts us right here. Down 1 puts us down there, and over 2 puts us there. And then we connect those 2 points, and we are good to go. All right. See if it cooperates. All right, so that's it. So go ahead and write a summary, a couple of sentences of what you learned, and that's how you graph the equation of a line.